Okay, so we looked at last week at the two key ideas that we're talking about within this part of energy. We're talking about energy stores. Let's make that bigger. Energy store. Oh dear. All right, we're going to try again. This time I won't be pressing silly buttons. So energy stores. These are how the energy, for want of a better word, exists. Is it electrical? Is it gravitational potential? Is it kinetic? What is it? And then the second idea is how it changes energy transfer pathway. On the Z, energy transfer pathways. These are two completely separate things. One is what have I got, and that's your energy stores. And the second one is how do I change it from what I got here to that? Right? It is the path it takes to change. All right. So energy stores we've done. We've got chemical, kinetic, elastic, magnetic, electrostatic, heat, thermal, internal, nuclear. This one here, I've just kind of slowed down on. Questions like this are not that straightforward because it doesn't give you enough information. Anything to do with something high off the ground is gravitational potential. Okay, now the energy pathways, as I said, there are three: mechanical, push-pull; electrical, you've got a battery, that's chemical; you've got a light that, well, emits light, and it's an electrical transfer pathway. We've got heat for your particles, conduction, convection, and then we've got radiation, how the heat gets to us from the sun, because there are no particles between us and the sun, well, apart from the atmosphere, but it's minuscule. So the heat has to travel through the vacuum of space, and it travels through the form of electromagnetic radiation or infrared radiation. If you see night goggles and play Call of Duty, well, you know what I'm on about. So like night vision goggles pick up on infrared. All right, so we have systems. Whatever energy is inside a system is the same coming out of the system. Now, here we've got a system, the Bunsen burner, which contains chemical energy. It is transferring heat energy by both convection, particle transfer, and radiation. So, and the transfer, that's the transfer pathway. The chemical store and the thermal store, they're the energy stores. The pathway is the heat transfer pathway. Okay. So another thing is, well, what's happening to my energy stores? As I burn fuel, which is chemical energy, the amount of chemical energy in the chemical energy store will go down. However, the energy, the heat energy, the internal energy store, the thermal energy store will go up. So they switch because you're changing one to another, right? Okay, so let's have a look at energy analysis. This is a drone. I like them. I've got one. I just don't get the time to fly them. They have a battery, which is a chemical energy store. When it takes off, it is moving up and getting higher. So its gravitational potential energy store increases. The chemical energy store, which is the battery, decreases because, well, batteries run out of power. Well, two things are happening. Well, actually, three things if you think about it. One, you're changing the battery's chemical energy into gravitational potential energy, it's going upwards, into kinetic energy, it's moving, and its internal or its thermal store increases because it gets hotter. Right? Okay. Now, the energy from the battery to the motor follows the electrical transfer pathway. From the motor to movement to kinetic energy, that's mechanical. All right. So somebody got as far as this, which was really cool fun. We got a little springy, bouncy, what is it? Hotel Transylvania kind of looking creature. Push it down. That's elastic potential energy. Let go of it. The elastic potential energy store goes down. The gravitational potential energy store goes up. Okay, here we've got a car high off the ground. I know it's not ridiculously high, but it's still high off the ground. That is gravitational potential energy store. As it gets to the bottom, its gravitational potential energy store has decreased and it's now moving. So its kinetic energy store has gone up. All right. The last thing I really want to talk about as you move through things are energy diagrams. Going back to the Bunsen burner, you've got it's getting hot because we're burning methane gas, which is chemical energy store, and you're heating up the water, which is its internal energy store, or its thermal energy store. It's heating in two ways. The really hot air going up and heating it up, and the infrared radiation. So there's two different energy transfers. We can make it really complex. That looks really complex. If you think about it, if I'm stood next to it, a number of things are getting heated. The water, hello, well done, I'm happy with that, but that was part of the question, so we know. The beaker, well, that's the equipment. All right, great. So the equipment gets hotter as well. And if I'm stood next to it, I get hotter, and I'm the surroundings. Okay. And that is the energy diagrams. I'm not going to go through everything. Oh, should I go through this one? No, I should leave it for that, for you guys to go through it. You are year 9, all right? So, yeah, give it a shot. All right. I'm going to stop